A mind-bending JWST image of the Orion Nebula, filled with rogue planets. Seeing the cosmic web, and an explanation for a massive star that just disappeared. All this and more in this week's Space Bites. All right, I've got a real treat for you today, and this is one of the coolest images of the Orion Nebula that I've ever seen. Of course, it comes from the James Webb Space Telescope, and it is just ludicrous. It's both like scientifically interesting, it is an enormous number of pixels, and so no matter what the resolution of your screen is, you got an 8K display, no problem. This can be your new screensaver. So first, let's just talk about like the image itself and kind of the aesthetics of it, and then we'll get into the interesting science that's going on. So the picture was taken with JWST's two versions of the NIRCam instrument. They did a short wavelength version and a long wavelength version. The short wavelength version of this image is 21,000 pixels by 14,351. And you're looking at a region of the nebula that's about 4 light years across. So imagine like the distance from us to Proxima Centauri, that's the amount of space that you're seeing in this image. And then the long wavelength version is 10,446 pixels by 7,109 pixels. So again, both of these images are gigantic, and the European Space Agency has a really cool slider so that you can go in between the two versions of the image and see what it looks like on different wavelengths. And of course, different wavelengths of infrared will reveal different kinds of features depending on the temperature of the gas and the stars and the things that are going on inside this image. So it is absolutely going to be your new background image for your phone, for your computer, everything. Put it everywhere. But the second part is that this image is scientifically interesting. And so the scientists who produced this image said that they found 540 free-floating planets inside the nebula. And so these are rogue planets. They're much less massive than what you would need to have fusion burning at the core of the star. So they're not red dwarfs, they're smaller than that. They're smaller than what you would need to get deuterium fusion inside the star. So they're not brown dwarfs, they are smaller. They are like Jupiters. And in fact, some of these go all the way down to about 0.6 Jupiter masses. So like a little more massive than Saturn. And again, they found 540 of these free floating. They found dozens that were like in binary configurations. And this has never been seen before. And so the astronomers are calling these Jupiter mass binary objects, or jumbos. And so like up until this point, astronomers know of dozens of rogue planets. I think they found about less than 100 last year. And suddenly you get 540 additional of these objects. And to see that there are this many of them in the Orion Nebula, it just sort of like blows your mind about the formation of rogue planets. Where do they come from? Like, did they form in place and just as a rogue planet of the amount of gas and dust required to make this object, or were they part of some larger star system and then all the interactions of the various stars kicked them out into their own orbits? And if that's the case, well, how do you get these binary objects that are floating together? And like, how many of them are out there? Like, if you think about how many of the stars are in the Orion Nebula compared to the amount of these free-floating planets that are potentially in there, when we think about the stars in the sky, how many rogue planets are associated with these stars in the sky? So like, we're at the beginning of like a paradigm changing understanding of what it means to be part of the Milky Way galaxy. I love this thought that although, you know, we think about Proxima Centauri, which is 4 light years away from us, there could be rogue planets dramatically closer, and that they could serve as stepping stones for, you know, some future advanced version of humanity where you're attempting to explore the Milky Way, and instead of having to go all the way to the nearest star system, you just have to make it to the nearest rogue planet and use that as a place to refuel and then move on to the next place. So I love the fact that they're finding so many of these. Old stars don't have hot Jupiters. Now, the first exoplanets that were ever found were, okay, fine. The first planets were found around a pulsar, but like around sun-like-ish stars, the first planets that we found were hot Jupiters. These are incredibly massive planets that are orbiting really close to their stars, closer than Mercury. They can take a couple of days, even sometimes a few hours to go around the star. And at this point, astronomers have found so many of these hot Jupiters that they can start to make some kind of assessment of how these work in general. They know of over 500 hot Jupiters. And from what they can tell, these kinds of planets only appear around 1% of stars out there. And now they're starting to correlate between the types of hot Jupiters that have been found and the types of stars that they tend to be orbiting. And what they found is that the stars tend to be young, that you don't get old stars with hot Jupiters. You find them around young stars. And this makes sense that whatever process causes a hot Jupiter to appear close to the star, that it can't be like a long-term viable situation. It's not balanced, that the interactions with other planets, the tidal forces between the star and the planet will cause it to spiral inward or get kicked out, and eventually that planet will be long gone. It makes you wonder, like, did the solar system ever have a hot Jupiter? Because the sun is 4.5 billion years, so lots of time to have its hot Jupiter phase. Probably not, because we have worlds like Mercury and Venus that are close to the sun. And so if there was a hot Jupiter there once, then we probably wouldn't see those planets because they would have gotten kicked out as well. So the fact that they're there tells us that the solar system has been stable for a long time, and so we probably didn't have a hot Jupiter. But if you want to find hot Jupiters, look for young stars. Seeing the cosmic web. When astronomers look out into the universe, they can see all of the galaxies, the galaxy clusters, the large-scale structure of the universe. But there is like an invisible part of the universe, but it's regular matter that connects and binds all of these different objects together. And it's called the cosmic web. And it is essentially filaments of gas that are streaming towards different galaxies. These inflows and outflows of gas allow galaxies to continue on star formation after they've used most of the gas in their home galaxy. And astronomers have been able to see some of it at various times. It's very faint and subtle and requires very careful observations. And so to really truly map out the shape and scale of the cosmic web, astronomers built a special tool. It's called the Keck Cosmic Web Imager, and it is a special instrument attached to the Keck telescope, which is one of the largest telescopes in the world. And what this does is it's looking for a very specific wavelength of light that comes from hydrogen gas. It's called Lyman alpha emissions. And so this comes from neutral hydrogen. When you have a large amount of neutral hydrogen, it will occasionally put out a specific wavelength of light, and you can detect that light and detect its presence. And so this camera system is specifically designed to watch for that signal coming from neutral hydrogen. And so because it does this one job, they were able to map out the shape of the cosmic web across the universe. And it's even trickier because in some cases, this signal has to go through intervening clouds of gas and dust, and it has to come through at higher and higher redshifts as the places are farther away from us. And so this system is able to account for all of these, and they're able to produce these kind of incredible maps of where all of this neutral hydrogen is, and then compare it against where all of the actual things that we can see, where all the galaxy clusters, and other objects that are visible. And then you can subtract, and that will tell you kind of where the distribution of dark matter is across the universe and get a much better sense of the large-scale structure of the universe. The mysterious case of a star that disappeared. So in 2009, astronomers noticed that a very large star just disappeared, and it had all the signs that it was going to go supernova. So they believe that the precursor had about 25 times the mass of the sun, and then it started to brighten up about 1 million times brighter, and then it just disappeared. And so normally you get a significant explosion. A star with 25 times the mass of the sun, you'd expect a very powerful supernova, and it just didn't happen. And astronomers were wondering, why did that happen? And so one really popular idea is that it's an example of what's called an unnova, or a failed supernova. And so, when you think about a supernova, you've got this large star, very massive star. It runs out of fuel in the core. The outer layers start to collapse inward. And then you get the black hole or neutron star forming in the middle, and then the whole thing kind of explodes and bounces outward, and you get this bright flash. But maybe the conditions would be so perfect that as this infalling material is coming in, it forms a black hole, and the black hole is able to efficiently gobble up all of this material without actually causing the supernova. And so the star just kind of implodes in on itself and disappears. I mean, it's still there. It's now just in black hole form. And this was a mystery, and astronomers had imaged the region with the Hubble Space Telescope, and they didn't find the star. And so finally, they did some follow-on observations with James Webb, and they were able to find a faint glow of some infrared object in this region. And in fact, they were able to find 3 objects in the region. And so the new theory is not that it was one of these failed supernova, but actually it might have been a merger between multiple stars that had all come together. It had glowed more brightly, but it wasn't sort of enough mass and material in a small area to detonate as a supernova. And so maybe that's an explanation that it wasn't a failed supernova after all, but just a merger between multiple stars. Every week we do a vote on our channel for what you thought was the best story of the week. And so this week, the winner by a landslide was OSIRIS-REx retrieving samples of Bennu and bringing them back to Earth. And we're sort of in the middle phase right now. We're waiting for a new announcement from NASA to really tell us what they got. We know they got about 250 grams of material from Bennu, but like, is it rocks? Is it dust? Are there good answers in there? We're about to find out. So thank you everybody who voted. Now, if you want the best chance to see this vote show up every week, make sure you subscribe to the channel, and then we will post it into the community tab. And so as you're scrolling on your phone, watching all these videos, you'll see our vote come through. Give us a vote and then just keep moving. The Milky Way might be less massive than previously believed. What is the mass of the Milky Way? It's actually a really tricky question to answer because we are inside the Milky Way, and so it's hard to measure. It's kind of like saying, how big is this forest that you're standing in the middle of, right? You don't know because you have to get outside the forest and then take a look. And astronomers have done several methods of measuring the mass of the Milky Way, and the assumed answer is about 1 trillion times the mass of the sun. And so thanks to Gaia, astronomers have been able to do a much more accurate measurement of the mass of the Milky Way. And the way they did this was they watched the motions of stars as they orbit the center of the Milky Way. There's a specific place in every galaxy where the speed of the stars that are orbiting around the center of the galaxy slows down dramatically. Astronomers call this the Keplerian cliff. And so they were able to look at all of these stars in Gaia data, and they were able to track the position of the Keplerian cliff inside the Milky Way. And when you do that, you actually get a really nice estimate for the mass of the entire Milky Way that's causing these stars to orbit around the center. And the number they got was shockingly low. So they estimated that it's only about 200 billion times the mass of the sun. So 1/5 the previous estimates. And if that's true, then it dramatically decreases the amount of dark matter that is located inside the Milky Way. Now, you might be saying, wait a minute, does that mean that like we're overestimating dark matter for all these galaxies? Well, no, because for all those other galaxies, we can see them from afar and we can measure the speed of the rotations of the stars in the galaxies quite nicely. And that's how the estimates for dark matter were discovered in the first place. And so it looks like the Milky Way might just be an outlier for what is a sort of standard mass galaxy. Like, we're really finding a lot out about the Milky Way, that in fact, the disk is warped, that it's probably has a dark matter halo that is tilted off axis from what the regular shape of the Milky Way is, that it might be a lot less massive and have less dark matter than we thought. And these really difficult observations required a mission like Gaia. So, man, I love Gaia. New Horizons is safe. Now, we've reported a few times now that NASA's New Horizons missions, the science operations were on the cutting block. And so maybe NASA wasn't going to continue funding the science operations of New Horizons beyond the next couple of years. And there was an outcry from the scientific community. And good news, NASA has decided that they're going to continue funding the spacecraft through to the end of the 2020s, so 2029 and beyond. And that's important because that gives the mission enough time to find a new target, another Kuiper Belt object, and then use that as a destination to explore more of the Kuiper Belt. And then at about 2029, New Horizons leaves the Kuiper Belt, and then the chances of them finding other targets go down dramatically. But it still has plenty of energy in the tank. It still has lots of juice in its RTGs, and so we can expect it's going to be able to continue doing science operations. And now people will be able to get salaries to do this science work. So good news for everybody on the New Horizons team. Now, as you probably know, we do a question show every week where I answer your questions about space and astronomy. And I've noticed that the number of questions is starting to go down, which is kind of tricky for me because I've got to decide, am I going to answer the same kinds of questions that I've answered before, or am I going to give questions much longer answers? So I need more questions. So just keep that in mind. Like when you're watching one of the question shows or really just any episode across my channel, and if it just triggers some like, man, I wish I could know more. I want to understand this better, or isn't this different from this thing that I heard over here? Or what did you think of the latest episode of For All Mankind? I want to hear your questions, and then I can answer as many of them as possible and get the really good ones. Like my favorite kinds of questions are the ones where like, I don't know the answer. I've got to do some research. I've got to talk to some experts. I set up a post on Mastodon and people argue about the answer. It's a lot of fun. So please, if you have a question, do not hesitate to ask it in the comments, and I or somebody else will attempt to answer it, and then hopefully I'll be able to feature it in the show. 2 supernovas struck the Earth in the last few million years. Supernovae are ridiculous. And like when a star detonates as a supernova, it can like outshine the rest of the entire galaxy. And so you can see why it's bad to have a supernova go off close to us. And yet it's inevitable. It's happened in the past, it'll happen in the future. Eventually a supernova is going to explode very close to us. And when this happens, like you imagine like the supernova goes off and like you're caught in the blast wave and it shakes your planet apart, but it's nothing like that. Instead, what happens is you get this really bright flash of gamma radiation that interacts with the Earth's atmosphere and strips away large portions of the ozone layer. And now life on Earth is unprotected from radiation in space. And so it can lead to gigantic die-offs on the planet. And so we would not want a supernova to go off close to us. And good news, there are no potential supernova within a dangerous zone of us that we can find. And so we are good for hundreds of thousands, maybe millions of years. But supernovae have gone off close to us in the past. And so astronomers were able to work out when some of the most recent supernovae hit planet Earth. And they did this by looking for a very specific isotope of iron, iron 60. And they were able to correlate between samples, say, in sediments, samples in rocks, and even moon samples to find that one supernova hit us about 3 million years, and another supernova hit us about 7 million years ago. And both of these supernovae were relatively close, within a few hundred light years of us, which is close enough to cause some damage, but not like catastrophic damage to planet Earth. And when you think about, say, Betelgeuse, which is at about 500 light years away, like that's the closest star that we know of that is going to go off at some point in the next, I don't know, 100,000, 2 million years. And even that isn't going to cause us any damage, but still we could, future archaeologists would be able to detect the presence of the iron that came from Betelgeuse when it hit us and caused a falling of iron onto planet Earth and onto the moon. And speaking of supernova, people always ask me, like, can we see things changing in the night sky when you look at images from the Hubble Space Telescope? Like, why do they have pictures and not video? And the reality is that things unfold so slowly at cosmological scales that you really can't see anything change. But if you take images over long periods of time, you can see some objects change. And there's plenty of examples of this from the Hubble Space Telescope. And one is the Cygnus Loop. And this is one of the closest known large supernova remnants. It's about 120 light years across, and it measures about 2,600 light years away from us. And it's a favorite target for amateur astrophotographers. I've taken pictures of the Cygnus Loop. It's one of the easiest things to find. But Hubble's been watching this for 20 years now, and so astronomers were able to release a comparison of what the nebula looked like 20 years ago and how it looks now. And you can see these really bizarre threads of material in this expanding cloud of debris, and watch how it's changed over just 20 years. All right, I'm going to give you an update on the book club, but first, I want to thank our patrons. Thanks to David Richards, Mark Anstis, Joel Yancey, Antonio Lofilara, Dustin Cable, Just Paul Davis, Vlad Shiplin, Jay Dennis, David Giltonad, Modso, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verbeoff, Andrew Gross, and Josh Schultz, who support us at the Master of the Universe level, and all of our other supporters on Patreon. About a year ago, we started up the book club, and I've been having a lot of fun reading the book recommendations that you've been giving me. I think I've read about 20 books in the last year, and as I read new series and give you updates, that generates more book recommendations. But I'm out of books, so I need more books. What I want you to do is go to the link on our Goodreads list and you can suggest books in that big list. I'll add it to my reading list, and I will make my way through the book list, and I will tell you what I thought. And the book club is very simple. You tell me what you want me to read, I'll read it, and I'll tell you what I thought. And then hopefully other people who are looking for good books to read will be able to find that there. So thank you in advance for everybody who's about to recommend all of their favorite books to me, at me. I can't wait. And definitely recommend books that are just like one-offs. We learned our valuable life lesson, which is to not get bogged down into a big long series. So what's a great one-off book that I should read? All right. Hope you enjoyed the news this week. We'll see you next time.